So this lesson, we're going to start talking about neural networks, and the first lesson is really just an introduction to the idea of what we're trying to do with this model. So I'll just get started. I know I got a lot of stuff kind of written in here. I'm going to go through it, and then we'll come back and we'll come back around during class tomorrow and hopefully do a little bit of programming. And I know this goes along with the Jupyter notebook hopefully as well. So if you haven't had a chance at the end of this video, go check out the Jupyter notebook and make sure you kind of understand the code that's in there. So the idea of machine learning is basically what we're trying to do is find those curves. In the case of today, for the most part, it's not a curve but a line because we're not using any hidden networks or I'm sorry, any hidden layers or anything. But basically find that curve and a line can be a curve that separates our data so that we can figure out if something's classified as one thing or the other. So that's the idea behind it. A neural network is an example of a machine learning algorithm that uses data to train the network. We need lots of data usually for a neural network to work very well. And it classify and in order to basically to classify new data, right? So you use old data, set up sort of show the network what it's supposed to look like or what different things are classified as, and then you come back and put new data in, and you can do a really good, hopefully a really good job of classifying that new data. All right, here's a simple example, and really this simple example is not to mean to show you what a neural network is, the power of it or anything. It's just to kind of get you to understand some of the notation and the ideas behind it, right? So obviously this is not how you would use a neural network. This is kind of a knucklehead way of doing it, but it's something that hopefully helps you kind of understand. So right now our model, we want to build a model that converts kilograms to pounds. And our model right now, without any research at all, we just go W11 is equal to 0.5. I have no idea what goes in there, right? Well, I do now because we just worked through it. But at the beginning, maybe you don't know what, so you just kind of initialize weights to whatever they should be. Then you come back in and you say, all right, so I have one piece of data, and you only need one piece of data in order to train this network. But our one piece of data is that when X1 is equal 100 kilograms, Y1 is 220 pounds. So X1 being the input into the network, and Y1 being the expected outcome of the network. So that's our target, if you will. So a lot of times you'll hear people talk about target or whatever. In this case, we're just going to call it Y1. So in this case, I'm going to put 100 into X1, and so here's another thing. I just want to make sure that you guys understand some of the nomenclature involved in neural networks. And so one of the things is layers. So you have input layers, and you have, usually this is called a final layer. I'm sorry, output layer, but we're going to call it a final layer only because of notation. So you'll see me put O's over here in different things, but I just make sure that when I say final layer, I'm also talking about the output layer that most people use when they talk about the neural network. Usually the output of the network. So we're going to put 100 in here, and so what happens is it goes in, so nothing happens to it inside this little bubble, and it comes out, and then I see a W11. Remember our model, 0.5 times 100, so out pops 50. So that goes into here, nothing happens, pops out, and 50 is our output. So basically this thing right here is telling you what we're doing. Basically take the weight, multiply it by the X1, and that becomes your output for this particular model. That's not true all the time, but in this case, that's what we're doing. And we found out that because we know the true value, right, the target should have been 220, we know we got some error. So we got 170. So if you did the subtraction here, you'll see that it's at 170.5. So the idea behind a neural network, so the idea behind these networks is that we're able to find a way to use the error to fix the weights. So that this sort of big idea right here is one reason why I wanted to introduce this simple example so that you understand that now I'm going to use this 170.5 in order to fix my W11, right? So that's my model right now. Nothing else persists in this thing. The data kind of goes away after you use it, but using that error in order to update my weights is really what we want to do. So if you come in, so the question is, well, how are you going to do that? Well, we know right now that I'm calling it W11 old, right? Because I know I need to adjust it. And I'm going to say that in general, W11 new is going to equal to W11 old plus some delta. I don't know what that delta is, but that's our job to figure out right now. I want to know what that delta is. I don't want to know. I want to know a good method of adjusting our weights in order to make our model good. And so if you just start off with, y1 minus o1 old is our error, right? So it's just what we calculated up here. This is our target minus our old output is equal to our error E1. And then so again, just kind of y1 minus what do we want to have happen? I guess is the question. We want our target minus our O1 new to equal 0. I put a little line through that to indicate that that's a 0. But what does that tell you? So if this is really what we want to have happen, then that means that y1 must equal to O1 new. So then I can just substitute that into here in order to get, come over here and you get this. So we want O1 new minus O1 old to equal E1. Well, how did we get O1 new? Well, it's just W11 new times X1 minus W11 old times X1, right? So again, just the way that you calculate these things. And then if you just sort of bring out the X1 out in the front and you do the subtraction here, you see that's equal to E1. And then what are we going to do here? Well, I'm really looking for W11 new. So I'm going to solve for W11 new. So W11 new is equal to, so all you do is a little bit of algebra here, and you get the E1 divided by X plus W11 old is equal. So that is what we want, E11 new. And when you start comparing these two equations, you note that the thing that, so W1 old is here and there, and the delta W11 is really this E1 over X1. So if I want to find out what I need to add to my old weights, well, it's just the error divided by X1. So if we do that, we expect to get a really good model. At least that's the hope. And so for this example, you see 0.5, 170.5, and 100. So our new is going to be equal to W11 old plus our error divided by our X1, and you find out that it's 2.205. 2.205, and if that becomes your new model and you put in 100, so that you don't really do this in practice, you don't put your old data into, well, I mean, you could kind of figure out if your model is being is giving you something that you expect, but in general you want to put new data in, but throw 100 in there, you get 220.5, and so I think that's exactly what it was. Yeah, 220.5. So we see that this new way of updating this, now this isn't going to have you going to update all of it. I just wanted to show that you need to find a way to use error in order to update your weights. That's the idea behind it. All right, so the next example here is basically to show you this part that I had labeled in red here. We want to show that that you need to learn incrementally. So that's what example 2 is talking about. So here's our things, right? I have 2 bugs, and I want to know if I classify the bug as a ladybug or a caterpillar, right? So I have 2 versions, or I have 2 examples. I got a 3-1, 3 being, I should probably put this. This is probably length of the ladybug. That's our first characteristic, our first feature, and this is probably width. So length and width here. So if you had a long, skinny bug, it's probably a caterpillar, and if you got a short, fat bug, it's probably a ladybug, right? So that's the deal here. And then without any knowledge at all, sort of initialize my weight. Y is equal to 0.25. And so what I want to do, I mean, this is kind of how I got it written here, with Y being my target. And if we use our first data point to update the weight, so you get 3.1, you put O1 in, you get 0.25 times 3.75, and then you just take the target, which is Y1 minus 0.75 divided by 3 plus the W11 old, and you find out that it's the new one is 1/3. And if you were to graph that out, it should go actually. Let me see if I can fix this. It should go right on top of caterpillar. Yeah, it should go something like that. So it's right on top of caterpillar. Not too helpful, right? So again, I'm trying to find the line in between these two that's going to do this classification. So I don't know. Let's find out if the next data point will help us out. And so use the second data point. You could do the same business. W11, 3 minus 1/3 over 1 plus 1/3. You end up getting 3. And again, Still not great, not real helpful, right? So we would like a line in between these two to sort of figure out which one's classified as which. But we're not getting that. We're getting every single time I put a new data point in, I'm getting one that's right on top of it. So of course that's not what we want. And so right here you can kind of see what I got written here. It says not helpful. So basically you're forgetting everything that you knew up to that point. So you're always using all the information in the very last data point. So that's not good, obviously. So I want to use this learning rate of 0.5. And if you do the same process again and you learn 3.1, but now instead of just taking this and add it to 0.25, if you take the error divided by x and multiply it by new, you get this new point, or I'm sorry, this new updated weight. Although this first one's still not helpful, right? So it's not even doing as good a job as the old one was, right? Because we needed to go up a little bit more. Check what happens when you learn 1.3. So if you learn 1.3, you get this 0.29, and W11 is now so the new W11. So put 0.5 in, 3 minus that over 1, add that, you get 1.645. And 1.645 looks something like this, which now is so now you're getting a little bit of the old, this point, and oh, by the way, wherever you started off at. So that's the idea. So we want to be able to remember, and the bigger new is I think it's the bigger new is the more recent data's valued. So if you want to put something really small in, then you're going to have a larger memory than you would if you get a really large number here. You can think about that for a second. So our model becomes this. Y is equal to 1.65x. And let's see. Yeah, let's go ahead and connect this to a neural net. So y equals 1.65x. So 1y minus 1.65 is equal to 0. So now what I want to do is I actually want to do some classification. So I claim that because y1 is what w1 is what we were multiplying by x. So in this case up here, x was I forget if I was length or width. X was my length and y was my width. So now I'm going to take, let's go back up here. I'm going to take negative 1.65 and multiply that by my my length, and then I'm going to take negative 1.65 times the length, and then add 1 or multiply by 1 times my width, and then we're going to do what's called use an activation function. So that's going to either give us a 0 or a 1. So this activation function is going to tell us whether the perceptron, so if you read the Jupyter Notebook already, you'll know what I'm talking about. The perceptron is either firing with a 1 or it's not firing with a 0. So let's come down and sort of check this out. So regardless of what happens in my my little multiplication here, right? So I'm taking W1, multiplying it by X1, taking W2, multiply X2. Instead of just reporting a number out like we've been doing so far, what I want to do now is I either want to give it a 0 or a 1, depending on sort of what happens with this summation here. So in this case, if I did I don't know, let's actually do the multiplication here. So 3 times negative 1.65 plus 1 times W2 is 1. So 1 times 1 is equal to, get my calculator here. So negative 1.65 times 3 plus 1 would give you negative 3.95. Because this number is less than 0, then we report a 0, right? Because that's what we're talking about here. If this thing is less than 0, then report out a 0. That's what this activation function does, and we'll talk about different activation functions later on. But this one's called the Heaviside function, so it's not terribly difficult, right? So you just do this multiplication, and then if you're less than 0, then report a 0. If you're greater than 0, you report a 1. No problem there. So let's find out what happens when we put the other one in. So I got 1 times my weight is negative 1.65 plus the other one is 3 times my weight is 1 again is equal to, if you do that multiplication, hold on, I get 1.35, which is greater than 0, so we report out a 0. 0. Report out a 1, right? Because it's greater than 1, so that comes a 1, and we classify that sucker as a ladybug. Now the next question is, well, what happens with this one, right? So obviously you can see that I'm trying to make that into a caterpillar. So hopefully that number is less than negative 3.95, but I don't know. Let's find out. Let's make sure. So let's put in a 2.5 times negative 1.65 plus 0.8 times 1, and that's equal to, give me a second here, 2.5 times negative 1.65 plus 0.8. And that's equal to negative 3.325, which we know comes out to a 0. So it is a caterpillar. Pillar, right? Caterpillar. Okay, and that hopefully that makes sense to you, right? Because that's what I was trying to get. So it's a cat. Yeah, so we'll go through this. I think that's all I got for this video. This is the very first introduction. What we're going to do next is we're going to do a little bit of programming, and we'll put this training algorithm in. So we'll start right here for the next video.